A warm welcome to all of you. In the continuation of concrete gravity dam forces after uplift pressure, there is another pressure which is called as silt pressure. Basically, silt pressure is nothing but when we are constructing a gravity dam over a flowing river and eventually the river carries a water along with silts, crushed stones, crushed rocks, pebbles, and similar kind of crushed material with itself, then this silt collectively put a pressure on the upstream face of the gravity dam. Basically, silt pressure has two components. First one in the horizontal direction and second one in the vertical direction, which is on the slope side. The value for the submerged density of silt for the sake of calculation in the horizontal pressure may be taken as 1360 kg per meter cube. This value of submerged density of silt is taken only for horizontal pressure, and the value for submerged density of silt for the vertical force, it will be 1925 kg per meter cube. So here we have to remember two values of submerged density of silt, that is 1360 kg per meter cube for or in the calculation of horizontal pressure, and 1925 kg per meter cube in the calculation of vertical forces. So this has to be remembered while calculating the silt pressure value in the horizontal direction as well as in vertical direction during the designing of concrete gravity dam. Now, the most important force is earthquake force. Earthquake force is also known as seismic forces, and this earthquake or seismic activity, as you all aware that this portion is has been covered in geology as well as in building design portion and in seismic and wind analysis as per RTO curriculum. But earthquake and seismic forces are also considerable in the gravity dam design. So I have to mention about what is the value or what is the earthquake or seismic forces. Earthquake and seismic forces are nothing but these are some activities associated with complex oscillating patterns of accelerations. These are nothing but the complex oscillation patterns of acceleration and ground motions which generate transient dynamic loads due to of the dam and the retained body of water. Horizontal and vertical acceleration are not equal, the former being of greater density. Vertical acceleration is always greater than the horizontal component of earthquake acceleration. Now the thing is that what do you mean by earthquake acceleration? Earthquake acceleration is nothing but usually represented as a fraction of gravity or acceleration due to gravity. Here a coefficient which is seismic coefficient, which is the ratio of acceleration force due to earthquake to the acceleration due to gravitational force. The seismic coefficient depends on various factors like earthquake intensity and the location. Location is nothing but the zone of country in which the structure is located. Along these two factors, the earthquake or seismic forces or acceleration due to earthquake is also depends on the elasticity of the material of the construction which is required for the dam and its foundation itself. So basically there are three factors which are the governing factors for the calculation or for the affecting factors in the calculation of acceleration due to earthquake. The first one is the intensity of earthquake. The second one is the location of the structure, in what zone in the country the structure is located. The third one is the elasticity of the material for which is being used for the construction of dam and foundation itself. So Bureau of Indian Standard IS code 1893202 part 1 criteria for earthquake resistant design of structures, fourth revision has been developed, which is very helpful while calculating the value of earthquake generated acceleration. This code divides India into five seismic zones. That means the whole nation is divided into five zones: zone 1, zone 2, zone 3, zone 4